Hello, today we're going to talk about force and motion. Okay, this is part 1, motion and speed, and this is PS10A. We're going to make measurements to calculate speed of a moving object, and we're going to apply the concepts of speed, velocity, and acceleration when we describe motion. So our essential question is, how are distance, time, and speed related? So if it's not written on your notes, you need to write this at the top. This is our main idea today. So motion. How can you describe the location of an object? That's our question for this one. And we can describe our location of an object based on the position and the reference point. The position describes the location of an object. Okay, so for this picture, there are three objects in the back of the wall: the sink, the toilet, and the bathtub. Right? When we compare these objects to known objects in the location, we can describe and use it to describe position of other things. So the gentleman here is on the right side of the sink. I use the sink as what we call a reference point, which is a location which you compare everything else to describe his position in the room. When he moves to the center, he's now on the right side of the sink. Okay? And when he moves all the way over to the right side of the room, he's now on the left side of the bathtub, the toilet, and the sink. All right, so motion. Continuing here, here's a map of our school, and we're going to describe the different parts of the school. So in class, we describe the different parts of our school. We said my room is down here in House A. We've talked about the gym is all the way up here. So there are different positions. And each house is on the left side of the school. Cafeteria is on the right. So we had a nice discussion about the different parts of the school. Right. And in a group, I had you guys draw. I was going to have you draw a large map and discuss the different things in my room in relation to the reference points. We did that with me in front of the class, and we talked about how when I'm moving around, my position changes based on the reference points, whether I'm on one side of the desk or the other side of the desk, if I'm in the center of the room, the back of the room, it all depends. Okay. So let's talk about speed. Okay. So what is motion and speed? Motion is a change of position over time. So even when motion is not observed directly, starting points and end points can indicate motion has occurred. So if you start at one part, right, and you end another, we can tell motion has occurred based off of your location in the reference points around you. So how do we measure distance? So earlier we talked about the metric system, and we say distance can be measured as a straight line between two positions, and we use rulers or we use a meter stick to measure this. It can be also measured as the total length of a certain path between two positions. We did that with our speed walking lab, or our wind-up toy lab. And what's really important is that the standard unit of length for distance is the meter. Okay? And that's the symbol for the meter. So let's take a look at this picture here. Okay. What's speed again? Okay. Which distance here would be greater? A straight line from A to B, or the total length of the path, which is this red line going around? Okay. In class, we talked about how A to B would be the shortest distance and should be the quickest speed, because since the distance is decreased, my speed or my time it takes would be less, which increases my speed. Okay. So A to B straight line should be your quickest distance and easier to get there. Okay, the distance that's greater is the red line. Okay. So what's average speed? Let's talk about average speed. I mean, we used some examples of cars. Okay, and a car has an average speed generally. So if you're on Route 7, you're going 55 miles per hour. That's an average speed. Okay? So speed is a measure of how far something moves in a certain amount of time. So speed also measures how quickly or slowly an object changes its position. So a car going down King Street is going to move a lot slower and change its position slowly versus a car going down Route 7, which is changing its position very fast in shorter times. So fast objects move farther than slower objects in the same amount of time. Okay. So we had a problem here, and the problem was with your shoulder partner. Your neighbor says she can skate at a speed of 1 meter per second. To see if you can skate faster, you have her time you as you skate as fast as you can for 100 meters. Your time, though, is 67 seconds. Who skates faster? So if you take a moment and take a look at the time. This took 1 meter per second. So if I look at it 1 meter per second to go 100 meters, okay, it would take me 100 seconds. Okay, but if you went 100 meters in 67 seconds, you're doing same distance but in less time. So the person, you, would be going faster. So average speed. Here is an example of average speed. So how do we calculate average speed? Speed can be calculated by dividing the distance of an object it travels by the time it takes to cover that distance. So a formula here. Please write these down. This is very important. Speed equals distance divided by time. So S equals D over T. And the standard unit for speed is meters per second, and it's M divided by S. Make sure you write each one of these down. Right, so here's an example. We don't use miles in science, but for this example it works. If I go 125 miles and it takes me 2.2 hours, I take 125 divided by 2.2 and I get 56.81 miles per hour. If I go 185 miles, which is further, and I do it in 3 hours, okay, if I divide that, it's 61.67 miles per hour. So they're a little bit faster because they had to cover a greater distance. Even though it took them a little longer, it didn't take them as much. Okay. All right. Here's another speed problem. Okay, please practice this on your notes. Florence Griffin Jr. set a world record by running 200 meters in 21.34 seconds. What's her speed? Be ready to discuss this when we come back. Okay, so you're going to take 200 meters divided by 21.34 seconds. Okay. We're going to do a wind-up toy lab in class. If you've already done it, great. If not, that's going to be coming. So our next part is distance time graphs. Distance time graphs are used to plot the distance an object travels over time. The distance of an object away from its reference point is plotted on the y-axis, and the time is plotted on the x. So here's our time. It's on the x-axis. The distance is plotted on the y. So objects moving at a constant speed make straight lines on the graph. So this is moving at a constant speed. Okay. So we're moving right here at our constant speed. Okay, straight lines. Okay. Straight lines. See that straight line? All right. Here's another one. Okay. On a distance line graph, a change in the slope of a line indicates a change in speed. So here we go. Here's our change in slope. That means it's getting faster because it's bending. We're changing our slope. The line gets steeper, the object speed is increased. So this is a steep line. This is a fast, steady speed. Okay, so as time goes on, we keep our distances going farther and farther. Fast, steady speed. The line gets less steep, the object slows down. If you look at the red line, it's a steady speed, but it's not as steep as a green. So it's not going as far in the same amount of time. And a flat line indicates zero speed. So this line is flat, is 0. It's not moving at all. If you go back to the last one, okay, nice steady speed, okay, but this one we're not moving at all. So as time's going by, we've stayed at 78 meters, looks like. All right. So here's another distance time graph. Okay. So our starting point's right here, our time's on the bottom, our distance is on the side. Okay, and as we go up, this is a steady speed. As time goes by, we're moving this distance away from our starting point. If we stop, it would be a flat line. And then if I start going down on a distance time graph, you're actually going back to the starting point. Okay. Your distance is decreasing as time's going by. So you're going back to your starting point. Okay. Velocity. The last thing we want to talk about is velocity. And velocity, this is a vector, okay, is a quantity that is both size and direction. So that's the first thing. An arrow, direction, if you're going north, that's a vector. South is a vector. West is a vector. Up, down. Whatever direction you're going, that's what we call a vector. Velocity is speed in a specific direction. So if I'm driving down the road and I'm going on Route 7, but I'm going east, my velocity might be 55 miles per hour east. So velocity is speed in what direction you're going in. So make sure you always write down the direction you're going in if they ask for velocity. All right. Average speed is just how fast you're going. When you come back, we'll play Four Corners as a review, and we'll do a couple labs and activities for the graphing. All right, see you guys.